Hello friends, welcome to my channel. This is part 2 of our chapter 11 of BGAS video lecture series, and chapter 11 is about film thicknesses. So in part 1 I discussed about WFT and how WFT can be measured, what is the importance of WFT. Now in this part we'll discuss about DFT. So before starting this video, let me give you a brief introduction of myself. My name is Sandeep Anand. I am a mechanical engineer and I am having 14 plus years of working experience. My hobby is to share my knowledge, and I share my knowledge through my website, that is www.weldingandandt.com, and the second most through which I share my knowledge is my YouTube channel. It is youtube.com/weldingandandt. So uh, by my website and through my YouTube channel I share my knowledge. And friends, if you want to support my initiative, you can do that by joining my channel. See, after subscribing my channel, you see a join icon, and by pressing that join icon, you can financially support my channel. So friends, these are my social media account, and here my Telegram channel is Welding and Identity. On this Telegram channel, I have already uploaded many standards, codes, and study materials, so you can easily search and download those study materials, and you can study those. So let's start with our today's video, and in this video, we'll understand how to determine the dry film thickness. So dry film thickness can be determined by the following four ways. First one is a test panel. By using a test panel, you can determine the DFT by using calculations, by using destructive test cases, and finally by using non-destructive test cases. So with all these four methods, you can determine the dry film thickness. So we'll start this video with the calculation. First, I'll explain how we can determine the dry film thickness by using calculation. Then I'll explain the destructive gauge. Then I will explain the test panel. And finally, I'll explain the non-destructive test. So we'll start with the calculation. I'll show you the formula. The first formula is WFT equal to DFT into 100 by percentage VS. VS is volume solid. And the second formula is WFT equal to V by A, volume by area. So if you carefully look at this formula, then you can conclude that in not only DFT, you can calculate WFT also, or you can calculate volume solid also. See, if you know the value of WFT and percentage VS, then you can calculate DFT. Or else, if DFT is given, and if you have to calculate the WFT, that also you can do that. See, if in a particular question they have mentioned that that some DFT is there and volume solid is there, then you can also measure WFT. So we'll start with some questions to understand. Like question number 1 is, if 12 liters of paint was used to cover an area of 10 meter by 10 meter, what would be the average WFT? So in this question, they have given two inputs, that is paint volume. Volume of the paint is 12 liters, and they have given the area. The area on which this paint has been applied is 10 meter by 10 meter. So the average WFT it is asking. So we'll use our second formula, that is WFT equal to V by A, means wet film thickness is equal to volume by area. So to use this formula, first we'll convert our volume and area in centimeters. Now 1 liter is equivalent to 1000 cubic centimeter. You have to remember this, that 1 liter will be equal to 1000 cubic centimeter. So in the question they have mentioned 12 liters of paint. Volume is 12 liters. So 12 liter will be equal to 12 into 1000 centimeter cube. Why? Because 1 liter is 1000 cubic centimeter. So 12 liter will be 12 into 1000 cubic centimeter. Now second one is the area is given is 10 meter by 10 meter. So that also will convert in centimeter. 1 meter is equal to 100 centimeter. So 10 meter will be 10 into 100. So 10 into 100 centimeter by 10 into 100 centimeter. That will be equal to 10 lakh centimeter square. So we have converted our volume and area in centimeters. Our volume is 1000 centimeter cube and area is 10 lakh centimeter square. So we'll put that in our formula. Formula is V by A. So volume is 12,000 centimeter cube and the area is 10 lakh centimeter square. So after calculating, we'll find this value 0.12 centimeter. So this is a very less means uh, dimension. We'll convert this into microns. Now 1 centimeter, read this line, 1 centimeter is equal to 10,000 micrometers, and micrometers is nothing but microns. You will always see that paint is mentioned it, or the unit of paint we usually mention is microns. So 1 centimeter will be equal to 10,000 microns. So our answer is 0.1012 centimeter. We'll convert it into microns. So 0.012 centimeter will be equal to 0.012 into 10,000. That will be equal to 120 microns. Microns or micrometer. So our answer will be WFT will be 120 micrometer or microns. 120 microns. So option B is the correct answer. Now, second question. This is question number 2. I have wrongly written it as question number 5. So question number 2 is, if 50 liters of paint was used to cover an area of 12 meter by 8 meter, what would be the average wet film thickness? So this question is almost similar to our first question. Means in this question also they have mentioned the volume of the paint and the area on which it has to be applied. So simply volume by area will be equal to wet film thickness, and you have to convert the volume as well as the area in centimeters. So volume will be equal to 15 into 1000 centimeter cube, and area will be equal to 12 into 100 into 8 into 100 centimeter, that is 99 lakh 60,000 centimeter square. So we'll divide both and we'll get 0.156 centimeter. Again, we'll convert this into micrometers, that is multiply by 10,000. We'll get our one answer as 156 micrometers or 156 microns. So WFT will be 156 microns. Option B is the correct answer. Now we'll see another question number 3. So this is question number 3. Now what WFT would be needed to give 50 micrometer or 50 microns DFT using a paint with VS 65%. So volume solid is 65% and give 50 DFT. DFT is 50 microns. So you have to calculate the WFT. So we will use our second formula, that is WFT equal to DFT into 100. WFT equal to DFT into 100 by percentage volume solid. So our DFT is 50 micrometer and percentage volume solid is 65. So DFT into 100 by percentage volume solid, that is DFT is 50 into 100 by 65. So our answer will be 76.92 microns. 76.92, that is option B is the correct one. Now we'll take another question, that is question number 4. Question number 4 is, what would be the DFT if a paint with a VS content of 45% was applied at 120 microns or micrometer WFT? So in this question, he is asking about the DFT. So in our initial formula was WFT equal to DFT into 100 by percentage volume solid. By cross multiplication, we can easily find out the DFT, like WFT into VS divided by 100 will be equal to DFT. So here I have written DFT equal to WFT into percentage volume solid by 100. So this is simple arithmetic. Now our WFT is given as 120 micrometer in the question. 120 micrometer is the WFT. So 120 micrometer percentage volume solid is 45. So by putting it in the formula, we'll get the answer as 54 micrometers. So our answer will be 54 micrometers, and that is in option A. So the correct answer is 54 micrometers. Now, next question, that is question number 5. What would be the VS percent? Now in this question, he is asking about the VS percentage if of a paint if it was applied at WFT of 110 micrometer and the DFT was 63 micrometers. So in this question, they have mentioned WFT and DFT, and you have to find out the percentage volume solid. So we'll use out this formula only. And in this formula, WFT is given and DFT is given. You have to find out the percentage volume solid. So by cross multiplication, VS will come this side and WFT will come at the bottom, and DFT into 100 will remain at the same position. So we'll put all these in formula, and the answer will be 57.27. So 57 0.27 is not given in neither in A nor neither in B nor in C. So that is D is that is none of the above will be the correct answer. Now, friends, with this we have come to an end our question for these calculations. I hope you will be able to understand. If you are not able to understand, then please stop the slide and look at the entire calculation. Hopefully, you will be able to understand. Now, we have understood about the calculation. With the help of calculation, how you can find DFT, or else how you can find the DFT, how you can find the WFT, and how you can find the percentage volume solid. So we'll move forward, and now we'll read about the destructive test gauge. Means with the help of destructive test gauge, also we can determine the DFT of a paint. So normally in destructive test gauge, you have to physically damage the coating. So you will have to physically damage the coating. Means after the test, you will have to do the repair on that area. So this is one of the major demerit of destructive test gauge, because you will have to damage the coating, and since you have damaged that coating, you will have to do the repair also. Now, in non-destructive test gauge, a very popular gauge is there, that is magnetic gauges. That is, I'm talking about non-destructive test gauges. That is very popular. So in non-destructive test gauges, there is one gauge called as magnetic gauge. But we cannot use magnetic gauge in certain applications when our paint contains MIO. If our paint is containing MIO, we will not be able to use magnetic gauge. Why? Because the magnetic properties will be there in MIO, and that will lead to incorrect readings. Hence, if your paint is MIO, then you will have to either you will have to use the destructive test, or if you can't use the destructive test, then you will have to frequently check the wet film thickness, so that you will get the correct dry film thickness. So common destructive test gauges are paint inspector gauge. First one is paint inspector's gauge, and we'll study this in our video lecture series. The second paint inspector gauge is also called as PIG in short. Then the second one is Ericsson test drill, and the third one is Sabberg thickness drill. So we'll study paint inspector's gauge in this video. Now, in paint inspector's gauge, a small cut is done on the coating. That is, you have to physically damage that coating. And after, see, first you will have to draw a contrasting reference line. Then you have to do the cut. And after a blade is provided in the paint inspector gauge, and with that blade, you will have to cut the coating till the substrate. And after cutting, you'll have to use a scale or lens is given in the gauge itself, and on that lens there will be one graticule scale. And see, I'll show the photograph. See, this is paint inspector's gauge, right? Here you can see the black line is the reference line. A reference line has been drawn, and this white is the cut. So you have done the cutting. And how you do the cutting? There one blade will be there at the bottom of the gauge, and through that blade you will do the cut. After that, there will be a lens will be there, and through that lens you will see the depth of that cut, and one graticule scale will be there. On the lens there will be one scale, and through that scale you will have to measure the depth of the cut, and a chart will be provided to convert the graticule reading, the reading of on the blade, and through that chart you will be able to come to a conclusion of the thickness of the coating. Here in this photograph you can understand, this is your coating. See, this is your coating, and this one is your substrate on which the coating has been done. See, if you clearly see how many layers of coating is there. This is the first layer, then second layer, then third layer, then fourth layer, and then fifth layer. 5 layers of coating is there. Now, blade, you can see here, this one is the blade. So with the help of this blade, the cut will be done on the paint. Here this cut has been done, and through the graticule scale on the lens you will be able to determine the depth. So this is how it is done. Then a chart will be provided. The graticule scale will give the reading, and that reading will be multiplied by the chart which is given there, and then you will be able to come to a calculation of how much depth of the coating is there. So friends, with this we have come to an end of our destructive test. Now we'll understand how test panels are used to determine the DFT. In test panels, a separate 150 square plate is made, and this plate is made from the same material, from the same material from which the actual component has been manufactured. So same material will be used, and the dimension of the plate will be 150 by 150 and this plate will undergo the same operation, exactly the same operation as the main components. So whatever operation you are doing on the main component, like blasting, cleaning, etc., that same operation will be done on the plate also. Then after that, after, you can use adhesion test to determine the DFT, or to determine the strength of the paint, or you can measure the DFT also through that test panel. So with this test panel can be used. Friends, we have come to an end of our today's video. I hope you like this video. Please give your valuable suggestions and feedback. Thank you very much.